So, in the third place, we need to create the CNN app or CNN application for the minced dataset. What's the minced dataset? This the dataset contains the numbers, image. For example, 0 to 9. 0, 1, 2, 3, 4, 5. Every image contains the one number. For example, 4. For example, 3. And we can assign each picture to the specific number to detect by using the CNN. Okay? This is the case, right? You get it? Okay. It's the famous implementation in the CNN because in the first place, or in the first CNN application, the Les7-2, I think the researcher name, it builds the CNN application for this dataset. Okay? So we need to import the torch. Import torch nn as nn, and import torch optim as optim. Import torch vision transform as transform. This utilized for the what? For converting the image to the tensors. Okay? This is the basic transformation tool to what? To obtain the labels and the data from the image in the Pytorch. And from torch utils data, import data loader, because we need to download the whole the data relating to the minced application in here, and also we need to give the torch vision dataset. This is the basic library for the what? Minced. Okay? Torch vision datasets. Okay? So the import matplotlib.pyplot as plt. Firstly, we need to create defining the model or CNN structure. Class CNN can be defined with the nn module parameters. Okay, and def constructor is given in here like this one. Is the multiple arguments parameters, and super must contain with the the CNN and self parameter. Okay, so convolutional layers can be created with the self con 1 can be used with the nn con 2d with the dimensions of the 1 32, and kernel size can be given with the 3, and padding is assigned to the 1. Okay, and self con 2 is also created in here, 32 and 64. Okay, the rest of the parameters are the same. And also we need to give the max pooling layer like this one, the self pool. Okay, this is nn max pool 2d with the kernel size of the 2 and stride 2. And also we need to give the fully connected layer, right? The fully connected layer can be built with the self fc is assigned with nn sequential, right? Nn sequential, and nn linear can be defined with the 64 times 7 times 7 128 neurons. Okay, this is 64 coming from this term, 7 and 7 is the flattened output parameters for the for the convolutional layer. And after that, we can give the NN relu rectifier unit. And also we can define the linear 128 parameters, but the output layer must contain the 10, because 0, 1, 2, 3, blah 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 9 has the the 10 numbers, which means that we need to build the 10 outputs, right? Okay. After that, we can give the def forward function, self and x, right? This is the basic structure parameters, but in the forward we create the convolutional layers. Firstly, we can give the x with the parameters of the self pool, with the parameters of the torch relu, and with the parameters of the self con 1 x. Okay, we can do that, but in each step I split this definition into the into the 3 step, right? This is the identical of the 3 step, but in this case I want to use that like this one in order to teach you about how you can build the forward function. Okay, that's the reason of utilization of these things. And after that, we can also assign the self pool like this one, torch relu and self con 2 and x, right? And after that, we need to give the torch flatten. Just remember, what's the flatten? Yes, 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 because we need to utilize these terms in a 1D term, because we have the fully connected layer, right? Okay, x and 1. And after that, x should be assigned with self fc with the parameters of the x and return to the x, right? Or we can directly return these terms. This is identical, right? Right? Thank you so much, guys. Approve me, please. I need that. Okay, this is the yes. This section is the linear output neurons, because in the NN sequential terms we have the this pattern with the 128 neurons, but the 64 is the dimension of this term, 7 and 7 is the assignment parameter to convert the 2D to the 1D, because we have the flatten parameter in here like this one, and so max pooling reduce the number of the dimensions. These dimensions reduce to the 64 times 7 times 7, unity calculated normally. Okay, coming from the the parameters, because this is the 2D image, and so this NN sequential must be assigned to the 61 4 7 times 7. In the next example I will explain this literally. Okay, but if you have any question about these things, please search on the internet, because everything cannot be explained in this lesson. Okay, so I have no time for that. But this is directly related to utilization of the linear function body in the convolutional neural network. Okay, it's not an important parameter, because everything about the utilization of the NN.linear function is given in the documentary. Okay. The linear function. Okay. Thank you so much. This is true or not? Okay. This is true, right? Or wrong? Okay, thank you. So in the next case, we need to assign the random seed for reproducibility. For what? For the image, or the taking the random image from the dataset. Okay, torch manual seed 42, for example, and load the minced dataset by using the what? The transform. Okay, and this transforms utilize the compose parameter or function in here, like this one. This function is built with the definition of the transforms to tensor, because we need to do that, because the whole image converts to what? Tensors. And also we need to give the transforms, normalize these values within the what? Two parameters, because we have the two-dimensional data. 0.5, 0.5. What's the meaning of this? This normalization is just the grayscale format for the what? For this image. Okay? So after that, the train dataset can be obtained with the what? MNIST, and the root is assigned with the what? Dot data. This is the downloading folder for the MNIST dataset, and train parameter is assigned to true, and download is true if already this is not already installed in your computer, and the transform is the transform. Okay, it's the basic parameters, right? And after that, test is assigned with the root data, but this must be false. Okay, okay. So data loaders should also be given in here, like this one, the batch size 64, and train loader is the data loader in here. This is just for the what? For the downloading operation to your folder, but this is the what? This is taken whole the image data to the what? To train folder, or the to be used in the Python application. Okay, this just downloading whole the data, this term in here, but this is the obtaining the whole the pictures into the what? Into Python code. Okay, train dataset batch size is equal to the batch size, and shuffle is true. Okay, and also we need to give the test loader, like this one, and test loader, test dataset, and shuffle false, because we don't need to shuffle the test data because it's the test data, right? But this is data loader, the bigger L, I think. Okay. So firstly, we need to create the training model, like this one. Firstly, we create the CNN with these parameters. Okay, and after that, we need to build the criterion is equal to the what? The NN cross entropy loss function, and also the optimizer is assigned to the what? The optim, and this case the atom can be used, the model parameters with the learning rate of the what? 0.001. Okay, and after that, the training path can be given, the num epoch is assigned with what? The 5. Okay, 5 iteration is given in here, and epoch in range num epochs, and so for I and related images and labels can be assigned with what the enumeration of the what the basic code train loader. Okay, this is the basic syntax for the what the data loader function. If you have any data to be contained in the data loader, you can utilize by using these terms. This is the easiest way to obtain the whole image. But in your projects that I give, right, you can build the whole image and the data. This is one way, and this is the another way for the bigger data implementation. Okay, so firstly we need to give the optimizer 0 grad, right? And after that this gradient is equalized to the 0, and outputs must be created with the image, right? And after that the loss criterion is to what the output and the labels, right? And after that this loss should be backward, and optimizer step should be assigned, and this is the what? This is the cases of our training phase, right? Do you understand that? Oh, okay, thank you so much. If I plus percentage 100, this is the batch size, not the epoch size. It's the batch size. Okay, what's the difference between the batch and the epoch? Yes, or this one, right? You can see that this is this for the batch size, but this for epoch size. Okay. At each batch size we need to give the what? The print f. What's the meaning of the f in here? Do you know that? Format. Yes, format. We can assign any variable into the what? Into string character, right? And so the epoch plus 1 divided by what? What? Yes. You are so smart. I appreciate your help. Okay? It's not a killing. And so this step is also given here with the what? I plus 1 divided by what? Lan train loader, because this is the total batch size, right? Okay, thank you. And so we will also give the what? The loss term in here with the parameters of the what? The loss item. Okay. After that, test our CNN application. Okay, model eval sets the model in evaluation mode, which means that we can assign or put the model to the what? To the image or the test data. After that, correct term should be initialized with the what? With 0, and the total must be equal to the 0, which means that we can check the whole data and increase the correct term if the number of tested subject is assigned to true values. Okay, the total 1 is assigned to the what? To the total number of the test data. Okay, And after that, if we divide the correct with the what, with the total, we get the accuracy of the what, our algorithm. And so with torch Nogret, what's the meaning of Nogret? If we have this utilization, and then this is not the training phase, this is only the evaluation phase. We will inform. We have informed the Torch library by using these terms. And so for image and labels in test loader, the outputs should be calculated with what the model image, okay? And after that, the predicted torch max outputs 1. What's the meaning of this? In the binary cross entropy function or the softmax function, we have the correct answer at the highest probability of these 10 neurons, which means that one neuron at the output may assign to the 0.6, 60%. The other terms is the smaller than this term, which means that if we check the max output value, and we can assign as the predicted value. Do you understand that? Do you understand? What's the meaning of this? Yes. For example, we have the 3 choices in here, like this one, 0.5 and 7. And so what's the maximum probability level in here? 0.7. And so this is the whole 10 number has the probabilities at the outputs, and so the max one is the true one. Okay, this is just the code taking this one. And also we need to give the total number plus equal to the labels size 0 value, the total number, and correct term must be increased with the if the predicted is equals to the labels, this is true, and sum and item should be assigned in here. Okay, and after that the accuracy values of this term is calculated with the correct divided by total. Okay, and also we can give the f test accuracy is given with the accuracy values of the times 100.2f. okay, percentage, right? Okay, and then we can visualize some predictions after the correct terms of results can be used with the model eval should assign be here, and image and labels can be assigned with the next and iter. Test loader dataset can be assigned with the image and labels in here, and the outputs also assigned with the models and image. And then we have the output value or predicted value in here, and also the true values of the image and labels in here. Okay, after that we should give the predicted value like this one, the torch the maximum with the outputs and 1. Okay, and after that we can create the figure, fixed size 10 and horizontally 4, right? Tuple must be given. Okay, for I in range of 10 pictures. Okay, PLT subplot to 5 and I must be given in here, but +1 should be added. PLT im show should be given in here, the image I, and squeeze function should also be called in here, because the proper format to be used in the imshow function should be given to the squeeze form, because the image in the in the torch form. Okay, so squeeze this okay, and CMap is assigned with what, the gray. Okay, and PLT title should be assigned with the what, F. True values is assigned with the what, the labels, right? Labels I. And after that, the predicted, if the is the what, the predicted I, right? Yes. After that, PLT axis off. Yes. PLT show must be given. If I run this code, this is the downloading the train images, right? Yan Legend. And so this data contains the what, the whole the image pictures. And after that we have the one step in here, like this one. In the first place, the epoch 1 and 5, step 100 batch size. Okay, and we need to wait to what, to train the network in here. Okay, this is the time lapse of this term, epoch 5 and 5, and the batch size 7 times. Okay, at each step this batch is update these terms. And the final results is assigned to the what, to this term. The test accuracy is 98.92. okay, it's the high value for these terms, but in this case the 7 is 7 through 2 through 1 1 0 4 5 9 4 and 1. See that? It's the highest accuracy for the what, for the means data set. Okay, in your own project related to the ECG application, you will get some kind of results. Okay, there is no question. I will show you a new modeling technique for the dynamic systems. Okay, ODE pi. What's the ordinary differential equation? This is the simple representation of the state space application in the Python programming language by using the what, the Pytorch library. Okay, which means that we can import the torch like this one, the import also matplotlib.pyplot. This is the mechatronic engineering example about the what, the dynamic system or dynamical systems. Okay, firstly we can define the state space SS in here like this one. The A is the torch tensor with the what, with the parameters of these terms like this one, and this one. Okay, and 0.0 and 1.0. okay, and the final term 0 1 minus 1 and 0.5. okay, this is the A matrix, state matrix. Okay, and B is assigned with what, the torch tensor, the what, and .0 and 0.1. This is the simple implementation of the what, the mass spring damper system in the torch model. Okay, also we need to give the initial conditions like this one. The initial conditions x0 torch tensor is equal to the what, the firstly the position 0 and velocity is 0, right? And also we can give the u values in here with the what, the 10 Newton force. Okay, and also we need to give the dt 0.1. This is the time step, 100 milliseconds. Okay, and we can give the num steps in here 100. Okay, and also we can assign the x to x0 because this is the initial condition, and outputs must be given in the what? In the empty list. Okay, so the for I in range num steps. What's the meaning of this underscore? This is the empty space, or we can create the some for loop to the what? To the num steps without the parameters. Okay, just like that. So firstly, dx dt, the state space forward equation, can be created with the what? Torch mal mut mal mat mul. Okay, matrix multiplication a and x plus torch mat mul b times u, right? This is the system dynamics equation. So update term is equal to what? The earlier definition is that dt times dx dt. This is the discrete time linearization, or the approximation for the what? For continuous system, right? Okay, and after that we should give the what? The output append to the what? The x and numpy, right? We can turn the everything to the what? To the numpy. So after that can assign to the output into the what? The torch tensor outputs, right? And print, so we don't need to this print in here. Visualize the results in here. The time parameter can be given with the what? The torch arrange function 0 num steps times dt, right? This is the how many points included in this case, and the iteration is the dt, right? And plt plot function as the time and outputs 0, and the label is that what? The position, right? The first term is the position, second term is the what? Velocity, s. So plt x label is assigned with what? The time, and y label is the what? Is the amplitude. Okay, and also plt title is equal to the what? Dynamic or mass spring damper simulation. Okay, and plt legend must be shown, and plt show must be assigned in this case. And so if I run this code, and then we will get the what? The solution of the what? This dynamical system, right? We will get that. Any question? Okay, so how can we model this dynamic system? By using the neural network in the Pytorch application. It's useful, right? Or I think so. We can create the model, the neural network model, to represent the A, B, or this dynamical system as a black box model. Okay? This is the implementation of the R code. Okay. Yes, we can use recurrent neural networks, but in this case we just only use the feed-forward neural network, but you may use recurrent neural network. Okay, This is the best way to do what? To do time series data, right? Right? So, where 5 neural ode.py. Okay, this is the last code. Import torch and import torch nn as nn, import torch optim as optim, and import matplotlib pyplot as plt. Okay, and so firstly we need to define the A and B, the states matrix, right? It's the same as with this one. And so we can take sometimes about that, and also can give these terms like this one. This is the neural ode, okay? And also we can give the simulation parameters like this one, okay? And after that we can build the what neural network. Define neural network, and so class neural network like this one, and then module is given in the what def init function body, okay? So what's the super? Super is that the neural network and self must be given in here for each instance. Firstly we need to define the self. Layer 1 is assigned with the what, the nn, linear to what, input size and hidden size, okay? And so we need to give the what, the initialization function, the input size arguments, hidden size arguments, the output size arguments, okay? And after that in the second case layer 2 and a linear hidden size to output size, right? And also we need to give the activation layer in here and then linear rectifier unit, okay? So def forward self and x can be given in here. X is equal to what, the self layer 1 x, and x is equal to self activation x. And after that we need to define the output layer with the terms of the what, the x self layer 2 x, and we can return to the what, the x, okay? And then parameters can be defined in here. Input size. What's the input size in here? Input size? Yes. Hidden size. You can choose the 10. And what's the output size? 2, right? So the neural network model can be built with what, the neural network with the what, the input size, hidden size and output size, okay? Okay, after that we need to give the torch manual seed with the 42 and define loss and optim function. Loss criterion is assigned with what, the nn mse loss function, and optimizer is assigned to the what? The optim Adam. Okay, with the parameters of the neural network model parameters, and learning rate should be assigned with what? 0.001. okay, so training phase can be assigned with what? The inputs value. Firstly, torch zeros with the what? With the num steps input size. Okay, and after that d type torch float 32. This is also tensor because the torch zeros produce the torch tensors. Okay, and also we shall give the inputs, the output, targets, but with the basic difference. With that, the output size should be assigned. Okay, so for the training phase, for I in range num steps like this one, dx dt must be assigned with what? The torch mal mat mul a x0 plus torch mat mul b u. Okay, and after that x0 is assigned to x0 plus dt times dx dt. This is what? This is the our simulation time. Okay, you can simulate these terms like this one, and so inputs I should be assigned to what? The x0, and outputs target is assigned with the what? x0. Okay, so at each case we contain the whole the total true values. Okay, after that we need to normalize the data in here. This is the simulation of our data, and the input normalized standard data representation can be given with what? The inputs minus inputs mean dimension 0, and we can divide the whole the data with the standard deviation. Okay, dim 0. This is called the standardization of your data. Just like normalization, we can standardize this data by using this form. Okay, and also we can create the outputs like this one, just using these terms. The outputs normalized, target normalized, output target, and output target. Okay, so for the training loop we should give that the num epochs is equal to 1000 for epoch in range num epochs, and optimizer 0 grade should be called. The predictions should be assigned with what? Neural network model with the inputs normalized, and loss can be calculated criterion with the what? The predictions and the output target normalized, right? And after that the loss backward should be given to the model, and optimizer step should be called. Okay, at each step if the epoch plus 1 percentage 100 is equal to 0, and then print f epoch plus 1 divided by num epochs, right? And loss can be assigned with what? The loss item at 400. Okay, so this is the training phase of our algorithm, and this is the test phase. Just like that, the neural network model eval, and the output target predicted in this case normalized is equal to the neural network model with the input normalized. Okay, and then what? We should create the output unnormalized form. Output predicted equals to the what? This term times output target std dim equal 0 plus output target dot mean dim. This is the unnormalized form of our algorithm, because in the first place we have this term, but in a reverse order of this process we will get this, right? Do you understand that? Do you understand? Do you get it? Do you get it? In this case we subtract the mean value, divide by std, but in this case we multiply std and plus mean. This is the unnormalization of the what? This standardization. Okay, so visualize the results. The time is equal to the torch arrange in here 0 num steps times dt and dt. Okay, and plt plot time output targets the first position, right? Label pose. Okay, in the second place the one well, but true well, true pose, and after that we can predict to the what? The outputs predicted, right? And the one is right, pre, right? But we have the detach and numpy in here. We should give that because it's a tensor. Okay, output predicted, and after that plt x label should be assigned with the what? The time, and y is amplitude, and plt legend and plt show. Okay, if I run this code, see that? Okay, or we can change the learning rate in here like this one. We have the what? The less accurate model outputs. But if I increase the what? This term 10,000, See, it's more good, right? Or we can increase this learning rate in here. This may be reaching the more better results. These lines are identical at this case. Okay? Any question? No. This loss not 0 at this case. For example, if we have the 8 in here, okay. Any question?